Hi, in this video, we're going to take a look at DNS, Domain Name System. It's one of the more fun videos I've done lately that I enjoy, so let's get into it. DNS, Domain Name System. It's a hierarchical, decentralized system for naming computers, services, and other resources connected to the internet or to the internet. So what does that mean? Well, the main function of DNS is to translate domain names like www.google.com to the device's numerical IPv4, IPv6 address, like we see here. Well, why is that important? Because underlying protocols like HTTP, etc., rely on IP to actually deliver the packets. The IP needs to be an address. Routers and other devices, they have no idea where is www.google.com or how to deliver it there. We need a numerical IP address that's in the routing tables or part of a network address in the routing table. You know, DNS is such an essential component of the internet or intranet is that when it's not functioning properly, that people think that they can either not connect to the network or that something is wrong with their connection to the internet. It's also why you need to be careful that your computer's not getting some malicious address that some party is using. So when you go to a website like your online banking, you're not really going there, you're going someplace else. So that's for another discussion, but let's go ahead and get into this. So the simple view is we have a device on the right and we've gone and typed www.google.com. Well, it doesn't know the IP address, in this case we're just using IPv4 of google.com, but it does know an IPv4 address for its DNS server, which is 75.75.75.75 that you see in the upper right here. Okay, so it asks that server, it says, hey, 75 quad 75, what is the IPv4 address for google.com? And the DNS server will respond and say, oh, that can be found at 172.217.4.132. Now, our device can now go and ask 172.217.4.132, which is Google's web server, says, please send me your web page, and which it will do, send us the web page, and we can display that in our browser. So that's the simple view. Most users don't even understand. They just think they type www.google.com and up comes the web page. But let's look at kind of the reality. First, let's look at the participants. We have the client, that's us. The client side of DNS is called the Dns Resolver. It's responsible for initiating a series of DNS queries that will ultimately leads to some resolutions, get some IP address associated with the domain name, www.google.com. We have our recursive DNS server. This is known as a non-authoritative server, meaning it's not the authority on anything, but it's who we can ask. And you know what? It's going to take our query and then go and find it, resolve it for us. Okay, so it will go out and get the right answer. Okay, it's not the authority, but it will go out and find the right answer. So who might it talk to? Well, we have these what's called root name servers. There's only 13 of them in the world. They accept queries from the recursive name server and direct it to the proper, what we call TLD, top-level domain name server, based on the extension. Who are you looking for? Are you looking for a .com, a .net, a .org? Okay, because depending on which one of those you're looking for, I will direct you to the right TLD, top-level domain server. A TLD name server maintains all the information for domain names that share a common extension. Who are you looking for? If I'm a .com name server, I have all the information you need to know about anybody who's a .com or .net or .org. These are known as generic TLDs. They're not country specific, but they include all the information on, let's say if it's a .com name server, it will know everybody who's a .com. There's also country code TLDs. So if you're going to a country like .uk or .jp or something like that, they'll be able to direct you to the right name servers for that country. Okay. Finally, we have what's known as the authoritative server. These are the DNS name servers that contain specific information for a domain. And we're going to see how this works in just a moment. And they'll be able to return. They're not the web server itself, like www.google.com, but they are google.com and can tell you where www.google.com is. Okay, let's take a look at how this works. First of all, a client. We're running both IPv4 and IPv6 addressing on our client. If I do ipconfig all, I see I have both an IPv6, I actually have 3 IPv6 addresses, and DNS server address. Let me just explain a little bit about these addresses. Okay, so we have 2 global unicast addresses, IPv6 address and temporary. The temporary IPv6 address is used by your device anytime it initiates the conversation. The reason why is that this address is temporary. It changes. It gives you a little bit more privacy. So somebody can't track you based on your interface ID. Typically, a random number can also be your MAC address, but typically, well, if it's a temporary address, it is going to be a random number, and which will change. And that way, somebody can't be tracking you where you are, not just on this network or any network. So typically when we're initiating communications, if we're using what's called the privacy extension in IPv6, you'll have a temporary IPv6 address, and that's what will be used. We also have a private IPv4 address that will get natted to a public address. And we have 2 DNS servers, or addresses for our DNS server. We have an IPv6 address and an IPv4 address. Love reality, and I love IPv6, as you know. Okay, it's where we're headed. All right, so I'm on my Windows machine. I can just do ping, by the way, and you don't normally, because I run dual stack. I have an IPv6 and IPv4 connection to my ISP. I can just do ping, and 9 times out of 10, I will be just communicating over IPv6. But I'm going to force the issue here to ping-6 www.google.com. And there's the IPv6 address for www.google.com. Okay, if I want to see it for the IPv4 address for www.google.com, I can do ping-4. All right, this is my DNS cache. So the operating system, when it gets information, we're going to see how this works in a moment, but right now, I've been to google.com, both via IPv4 and IPv6. So my local DNS cache on my machine actually has the IPv4 and IPv6 addresses for www.google.com. So we can see here, let me start down here with an A record, because this is the IPv4 address. So that's what's known as an A record in DNS, okay, which is a 32-bit address. Well, what's 4 times 32? That's 128. So if 32 bits is A, 128 bits is a quad A record. That's where they get quad A. And here's my quad A record, the IPv6 address. Both of these are for www.google.com. And like I said, just most of the time when I'm communicating with Google, LinkedIn, Facebook, 50% of the servers out there on the internet are now IPv6 enabled, and all the major ones are. So if you've got IPv6 at home, you may not even know you do. Chances are you're using IPv6. You know what? Your mobile phone, IPv6. Okay, enough IPv6. Let's get back to DNS. All right. So I'm going to go ahead and flush my DNS cache. All right, because I want to force the query to ask my DNS server for the IPv4 and IPv6 addresses associated with www.google.com. So if I display the cache now, notice my cache is empty. All right, so let's see how this works. So here I have my client. All right, And I've done www.google.com. There's my HTTP GET, all ready to request the web page from google.com, but it's got to be encapsulated in, well, both TCP and IP. So it needs that destination IP address associated with www.google.com. So it checks its DNS cache. It's not in there. Okay, remember we flushed the cache. So let me send a query, okay, for both the A and quad A records for www.google.com. I send that to my ISP who has the recursive DNS server. Okay, again, it's a non-authoritative server, and these addresses down here, the DNS addresses I have, that's how I'm communicating. I know its address, IPv6 and IPv4. Okay, so my recursive DNS server has its own cache. If it knows the answer, it can respond to me right away. But we're going to say that it doesn't, okay, just so we can see everything that possibly it can go through, okay? So what it's going to say is, I don't know where www.google.com is. Let me ask a root name server, okay, I need to ask the root name server, hey, where's www.google.com? My root name server, which in this case is Comcast, is asking VeriSign, Comcast being my ISP. It says, you know what, I'm going to ask VeriSign. So VeriSign says, you know what, I don't know where www.google.com is. That's not my job, but I can direct you to a top-level domain server, actually c.gltd-servers.net, and I can give you their IPv4 and IPv6 address. Go talk to them. And I'm giving you the top-level domain name server for a .com TLD, because that's who you're asking for, www.google.com. So I'm going to give you the address of a .com top-level domain name server. So Comcast goes, okay, let me go ask this TLD server for a .com. Hey, TLD server, you're a .com TLD server. What's the address for www.google.com? The top-level domain server for the .com says, I don't know. But I do know where google.com is. I can't tell you where www.google.com is, but I maintain a list for all the .com. I have information for anybody.com, like google.com, linkedin.com, Cabrillo. Well, there wouldn't be a .com, there'd be a .edu server. But any of the .com, netflix.com. But I can't give you that www part because, you know, they have google.com has mail.google.com, has www.google.com. They might have ftp.google.com. So I'll just give you google.com and you ask them. So here's their address for that. Okay. Hey, google.com. So it sends I need the A and quad A records for www.google.com. Well, guess what? I am the authoritative server. I actually know, I'm google.com. I know where www.google.com is. So let me give you the A record and the quad A record for www.google.com. I'm the authority on this. Okay, so now our Comcast server has, and by the way, it's going to cache all various kinds of information, root name server addresses, TLDs, and even the www.google.com can all be cached in the recursive DNS servers, DNS cache, so it doesn't have to go through this every time for everybody that asks. Okay, so here we go. It finally sends back our response. This www.google.com is, here's its A record, here's its quad A record, depending what you want, IPv4 or IPv6. My client gets that, puts it in its DNS cache, so that's there now, and now can go ahead and send that HTTP GET request with the proper destination IPv6 or IPv4 address. Okay, All right. So you can also get this kind of information if we do NS lookup. This is a great tool. I'm just going to kind of introduce it here. If I do NS lookup for www.google.com, first of all, I see my ISP's DNS server address. So there's the address for my ISP's DNS server. Okay. It also returns, because I did NS lookup for www.google.com, it will give me both the A and the quad A records for www.google.com. Now, you might notice it says non-authoritative answer. Okay. That's because it says this is coming from, I'm not the authority on this. If it said authoritative answer, is if the DNS response came directly from the authoritative server, google.com. Non-authoritative answer is if the DNS response came directly from the DNS server itself. So I'm getting a non-authoritative answer because Comcast, my DNS server, had this cached in its DNS cache. So I had all this already stored. So it didn't actually have to go out and ask. It said, I already knew where google.com is, or www.google.com. So I'm the one that's providing the answer here. I didn't have to go out and ask the authoritative server. Okay, I could also do NS lookup google.com. Notice without the www. Okay, well, what I'm getting here is the address for google.com's authoritative server. Okay, kind of cool, huh? How we can see all this good information. Okay. All right, and if I did Wireshark, by the way, I could see my DNS query for the A record. I can see my DNS query for the quad A record. Okay, some operating systems can combine these into a single query and get a single response. Let's take a look at the responses. So there's the queries for www.google.com. Here's the answers. So here's our response, and you can see in the answer, there's our answer for the A record, the IPv4 address. And there's our answer, our quad A record for the IPv6 address. Okay, pretty cool stuff, huh? All right, so DNS name resolution. So on Windows, we can use ipconfig /display DNS to display the DNS cache. You can flush it with the /flush DNS. The TTL is associated with how long that entry will live in your DNS cache. The TTL is specified in seconds. All right, so I hope this helped introduce you a little bit to good old DNS.